In our last chapter, we talked about sourcing data. But now let's talk about data formats. The data we source could come in many different formats. When we say format, we mean the structure and encoding to represent information. There are several formats at 3 different points in the process. First of all, the data we source has a format. Second, we may transform that data and use it as input to analysis. And then finally, our analysis produces data as output, and it has some format. So they may all be the same format, or they may be different formats depending on what we're doing. Some formats are better suited to certain use cases than others, and we often will convert it from one format to another. And some formats map to a relational model better than others. Let's look at the example of log files. Many applications and services generate log files. For example, web servers generate log files. Every time a request is made to the web server, a log entry is made into the log file. Similarly, mail servers, Hadoop servers, cell phones, enterprise applications, lots of applications log data on every request. Log files can be a valuable source of information. A single click on a web server isn't that interesting, but 1 billion clicks on a web server is very valuable. You can really understand who your customers are, what they're doing at your website, how long they're staying, what they're purchasing, all by being able to analyze the log files across those 1 billion clicks. Log files are a lot of data. It's usually too expensive to store that in a transactional database. Instead, each log entry, each visit to the web server is added to the log file. And this information is structured. It's text, separated by spaces, another white space, and typically has information such as IP address, user ID at the client, user ID at the server, date and time zone, resource accessed by the user, return code, number of bytes returned, and browser type, as well as cookies and other parameters. So here in this example, we're showing not at scale, but under a small data, using Unix tools to parse out this various data here. For example, finding out the IP addresses that were accessing the log server. Another popular format is to have data in text and have the text separated by some character, a comma or a tab, or have fixed width fields. And this is common for data that's exported from databases or spreadsheets and then imported into other programs. Typically, it's 1 record per line with the fields delimited or the fields fixed width. Very popular format, of course, is CSV or comma-separated files. And comma-separated files can be deceptively difficult to parse. There actually is a standard for comma-separated files, but it came too late. Lots of applications were producing comma-separated files, and so there's many variants. And the variations are based on quoting, how you're going to embed commas, and how you're going to specify missing fields. XML, on the other hand, is a hierarchical structured file format. Also text. An XML document is a hierarchy of elements. And elements can have sub-elements. And XML is a self-describing format. So if it's well-formed and validated against a schema, then that's really good for processing data because you know that the data in the XML document meets the constraints as specified in the schema. XML documents can be a bit verbose because you begin an element with a tag name, and then you also end the element with the same tag name. HTML, or the hypertext markup language that are used in web pages, is related to XML because there's start tags and end tags. Syntactically, it looks similar, but it's not so strictly structured the way XML is. Basically, HTML is what any web browser will accept as valid input. If it shows a reasonable page for that HTML, then that's considered okay. So ending tags might be left out. Content and format intertwined, especially in older documents. JSON, or the JavaScript object notation, is an alternative to XML. It's quite popular because JavaScript is used on the web for web pages. It's a way of embedding programs, and so JSON is a way of taking a JavaScript object and transporting it over the network or storing it. And it's similar to XML. It doesn't have ending tags, but it is a hierarchical structured file format. There is support for JSON in many languages.